Right, so hello everybody. My name is Mircea Halmagiu. I work in one of the DevOps teams at Smartly, the more developer-focused DevOps team. And I'm going to talk to you guys today about GitHub Actions. And the thing that makes me qualified to do this is because the very adorable fellow over here with sunglasses, I'm his human. So I was one of the engineers at Smartly who worked primarily on the GitHub Actions adoption here. So let's talk a little bit about what we're going to cover during this chat. We're going to talk about the GitHub Actions usage at Smartly IO in general, and particularly its use for CI. We're going to try to take a methodical approach, and we're going to have a look at what development at Smartly looks like, why we wanted to change and improve it, and why we chose GitHub Actions. And then we're going to see that the methodical approach doesn't always work quite as well as we'd like. There's a couple of speed bumps involved in implementing GitHub Actions, and we're going to talk about those in some detail. Then I'm going to show you an example of the type of workflow we've come up with, and I'll give you some of the thoughts we've had in terms of how to carry on further. And I'm going to try and leave as much time as I can at the end for questions. So let's begin. Context is important, so that's where we're going to start. So what does development at Smartly look like? We use GitHub, and we have 300 plus repos. I didn't put a specific number there because it changes quite frequently. I think last time I checked it was 340-ish. It's a lot of individual repositories. We use TypeScript among many, many other languages. I'm mentioning TypeScript in particular here because the example I'm going to show you is for a TypeScript library. We have a mostly microservice architecture. Yes, there are some monoliths, but we're going to be talking about things specifically in terms of microservice, deploying microservices. And many of these microservices are built on libraries that we've developed in-house. And the specific example is going to be for one of these libraries. And we use Kubernetes to deploy onto. This presentation is going to be a bit like a B-grade horror movie in that when I mention something with a great deal of detail, it's probably going to come back later. So what does CI look like at Smartly? Well, we use Jenkins. A quick show of hands, who's used Jenkins before? Right. Now keep your hands up. Keep your hands up. Now lower them if you've never had any issues with Jenkins. Really? Okay. So we have a master with 18 workers, and these workers we actually run on physical hardware, and they're pretty beefy physical machines, 8 CPUs and 64 gigs of RAM. Now this is one of those details that's going to come back later, so just I'll mention it again. We have many wrappers and libraries that we've built to make life easier for developers. And everybody thinks this is very, very groovy. So there might be some issues, which if you've worked with Jenkins, you might be able to predict. We have occasionally got broken and stuck workers. We have hardware issues, which is the downside of running your own hardware. And occasionally, a broken build will break that pipeline until there's some manual intervention. Now, that could be optimized, but it is what it is. There are, however, some benefits. We have some pretty wonky setups. We have, for example, a RAM disk that's wrapped in a LVM that's passed to LXC to make LXC builds faster. And the other nice thing about this is we can literally throw more resources at it whenever we want. We can add nodes, we can make bigger, beefier nodes. It's great. So if this mostly works, then why change it? Well, the problem there is the mostly. So if we have something that's 99% of the time it works as it should, that's one failure every 100 builds. And I mentioned we have more than 300 repos. We do a lot more than 100 builds a day. And the other problem is that the developers aren't really feeling the groovy. So that means that there isn't really buy-in to CI from the developers. And this inevitably means that when you ask developers to fix their Jenkins file, it's a little bit like asking them to go get some teeth pulled out. And this inevitably ends up with, hey, you guys in the developer tooling team, can't you guys fix this for me? So I'd like to make it clear now, before we carry on further, that we're not aiming to replace Jenkins. Jenkins is quite adequate for most of the work we do. We'd like to experiment and maybe perhaps get some small improvements. And that was the mindset we had when thinking about GitHub Actions. So why did we specifically decide that GitHub Actions was the way we wanted to go? Well, it looks simple enough. The documentation all said it would be very, very easy. And whenever the documentation says it's going to be easy, it's right, yeah? The other thing is we're already using GitHub. That means it's already a single point of failure. If GitHub is down, we can't build. So we're not adding any new points of failure here. And as the name would suggest, it's pretty well integrated with GitHub. So sounds good. We can also build on Mac OS machines, which is very convenient. We have some internal software that we'd like to be able to build on Mac OS. And the hype is real enough. And what I mean by that is that, well, the developers actually want to get involved, which was a little bit weird for us. It's, since when did developers want to get involved the way CI works? So let's dive in. So we obviously took a very well-planned approach. It always works. Yeah, that's not exactly what happened, but this isn't always a bad thing. It let us figure out what it was that we wanted out of the CI and specifically out of GitHub Actions as we went along. We took a very iterative approach. Because the developers were interested in being involved, we could literally get them to be involved in the process. So we could go and say, hey, we came up with this really cool thing. What do you think? How can we make your life better? What does this need before it helps you out? The one thing to bear in mind here is that because it's a product that's relatively new, and we started playing with it while it was still in beta, failure is kind of unavoidable. And it's a new environment without very many examples, so you're kind of feeling your way in the dark. And we add to that the fact that it's quite difficult to run GitHub Actions locally. There was initially for the old HCL actions, there were local runners, but those don't work so well now with the YAML, syntax. So it's also important to note that some of the features that you build only can be tested actually in GitHub. So, for example, what happens when you merge to master? Well, the only way you can test that is by merging things to master and watching what the events look like. So we have to plan around failures when working on something like this. And we also decided to only automate certain libraries and a few Kube services to experiment with. We weren't going to go with all 340 odd repos and just try and get everything done, because the team isn't bigger than 4 people. So let's talk a little bit about libraries and Kube services and some of the specific problems involved. So libraries, and we're going to define libraries as a build that results in an uploaded asset rather than something that is deployed. And we usually use these assets for further builds. And we're going to look at these in more detail in a second, and this is where the example comes in, so I'm not going to talk too much more about these. But we have a mostly working solution for this, and we'll come back to the speed bumps in a second. But yes, Kube services. Now these are mostly the same as libraries, but they have one significant further problem, and that's deployment. You have to actually deploy this. You can't just upload it somewhere and somebody else will take it from there. You actually have to follow through with the deployment. And spoiler alert, there's some speed bumps involved in doing that. So what does our library build do? The entire deployment process is tied to PRs. So whenever a PR happens or a commit is made to a PR, we trigger a build and test. The results of these are visible to developers in GitHub. And when that PR is merged, we do the build and test, and we also upload the asset. So We've also decided to make another relatively large jump, and that is to use semantic versioning. And this is controlled by labels on the PR. You can add a major, minor, patch, or no release label. And depending on those labels, it'll choose what type of release to do. And there's optionally an option to fail the build if there's no label. So if the developer forgot to put a label, it would fail the build, and it wouldn't do anything further until a label is added. And semantic versioning is kind of a can of worms of its own, especially when you're using branch protection, and that could be the subject of its own talk, but we're going to just carry on past that as if those problems don't really exist. So this all looks fairly simple so far, right? And yeah, it's really, really simple. So simple, in fact, that it only took us a few months to implement. So onwards to examples. It's really simple, and no, we got some speed bumps. I think it's probably really nice to talk about the speed bumps before we actually get into the examples. It'll make the examples make a lot more sense. So it's important to note here that the situation is rapidly changing. GitHub Actions is under active development. This literally might not apply tomorrow. So have a look at all of this, and then maybe have a look at what their documentation says. So one of the first issues, and I mentioned this when we're talking about deploying Kubernetes, is deployment security. So one thing to note is that when you're running GitHub Actions, you're running on a pool of workers in Azure that is shared across everyone who's using GitHub Actions. That means your IP addresses are not unique. They're being shared with everyone who uses GitHub Actions. That means that using whitelists for deployments, for example, for a Kube API, is not really something that you can do because you have no idea who can actually use those IP addresses. Self-hosted runners are a solution for this. And there is an API. Oh, wow, I left out an E there. OK. There is an API, but we haven't actually finished the implementation, as you can see from the missing E there. Yes, there are also some missing features that would be very, very convenient. The first and most important of these is the fact that a lot of resources are tied directly to repositories, not to the organization. So, for example, if you want self-hosted runners or you want secrets, those are all tied directly to a repository. There is no organization-level self-hosted runners or secrets. Now, as I mentioned, we have 300 and something repositories. If we wanted to have the ability to deploy with a self-hosted runner for each of those, that's 300 self-hosted runners, most of which would be idle. Also, if we have keys or something, we'd have to add them to every single repo. Yes, there is an API for that, but maybe it'd be nicer to just have them all in one place where we can change them all at once more easily. There's also not very much in the way of aggregated or detailed metrics and statistics. There are some metrics and there are some statistics available, but it's very difficult to get a view on exactly what your usage looks like. It's very difficult to see, hey, my builds are actually beginning to take longer. Over the last month, we've had a 40% increase in build time for this project. That type of thing is actually quite difficult to ascertain with the current tools. There's also not very much in the way of simple and flexible notifications. So in Jenkins, you have the always block. You can have the always block, and on failure, notify, and on success, notify, or do whatever it is that you need to do, and that will always run. Now, the always is something that you can do in GitHub Actions. You can make a job and run it if always. The problem is you don't have information from any previous builds, any previous jobs. So you don't know whether the jobs you're talking about have actually succeeded or failed. So you can notify the build is done, but you can't really include information as to whether it was successful or not without integrating other tools. And integrating other tools is definitely a possibility, but you're using GitHub Actions. It would be great if it did all of this for you. The other one, which is a kind of take it or leave it thing, is private actions. So if you want to use a sub-action, currently it has to be open source. This hasn't really been a very big limitation. It's easy to work around, but it would be nice sometimes for specific tools to be able to say, hey, I don't really want this to be open source. I just want to hack this thing together, put it in there. Maybe, some bad practices, put some URLs or something in there. Makes life easier. Hasn't really been a problem. Would be nice to have. This is one of those infomercials where, but wait, there's more. So, documentation. Now, this isn't really such a big issue anymore, but when we first started, there really wasn't very much. And some of what there was kind of deceptive, where the documentation would say one thing that was technically correct, but would lead you down the wrong rabbit hole. Rabbit hole's probably the correct term. And there was also a lot in the way of documentation that referred to the old HCL syntax. That situation is already a lot better, but the thing that really made this quite a lot easier for us was a repository called Awesome Actions. And you can just search Google for GitHub Awesome Actions, and you will find this repository that kind of aggregates all the documentation, all the examples. It was super helpful for us. The other thing that is a kind of a big issue is security for third-party actions. So when you refer to Jim's upload to S3 at v1.4, well, what's actually sitting behind that v1.4? And there isn't really a way to know. It could be a tag, it could be a branch, those are all acceptable, but you have no idea what code you're actually getting. Someone could upload malicious code behind that tag, and that's what you would end up running. This is a problem, especially if you're passing credentials to that. So there's this very simple solution to that, and that is just fork it. Make a fork of the repo, open source, whatever. You know exactly what code you're executing. It's yours, you control it. Obviously, that poses problems in terms of maintenance, but at least you don't leak credentials. The other issue is itty-bitty nodes. So I mentioned we had fairly beefy CI nodes. Well, these ones are 2 vCPUs and 8 gigs of RAM. That's a slight difference from 16 vCPUs and 64 gigs of RAM. And this literally means that some builds can't run within the time limit, nor would we actually want them to. Things that take hours instead of minutes, not the direction you want to go in. And the lack of caching doesn't help with this either. There isn't really an effective way to cache intermediate build results or assets that you're using in your build. There are methods, but they all kind of negate the very nice looking builds. So that's a problem. And some of those crazy setups, they're not going to happen. This is all running on somebody else's virtual machine in Azure. So building a RAM disk that you're going to wrap in an LVM and pass to something else, not really a possibility. So let's have a look at this library build. The way we integrate this into a new project is quite important to understand. So the first step, and this is partially politeness, partially practicality, is maybe talk to the team that owns the repo. This is A, really nice thing to do before you start messing in someone's code base. And B, the more important thing perhaps is that what we're going to do is change the way releases work. And it's important that teams are aware of how this is going to change, because if they continue trying to release the way it used to work, it's going to end up breaking the release process. Once you've talked to the team, you add the required secrets to the repo, and you make a PR. And in this PR, you copy-paste the actual workflow, and you make sure that in this particular case, we're talking about TypeScript repo, so you make sure that yarn will do what you want it to do. We add a semantic versioning label to this PR, and we add branch protection to master, and then we wait for it to build. And once it's finished building, merge. You now have GitHub Actions for CI in this repo. And now a magical step happens, and then there's profit. Yay. So what does the structure of this action look like? It looks really, really simple. We have a name. We decided to call it something very mysterious. CI, we figured nobody would know what that means. And then we tell it what to trigger on. And we tell it it's going to trigger on pull requests against master. And it's going to trigger when the PR is opened, when there's a synchronize, which in our case, the most important type of synchronization action is a commit, and closed. And merge is included in closed. So you'll notice that there's 3 jobs: check labels, which is going to do the check to make sure that we have the correct versioning label. There's the build step, and then there's the version bump step. So let's have a look at each one of these jobs individually. The check labels job also includes, let's start from the beginning. We run it on Ubuntu 18.04, and one of the things I don't particularly like about the documentation is it tells you to use Ubuntu latest, which is great, except for when latest changes. So we specified 18.04 because that seems like a good thing to specify. We have two steps, an optional step that will check if there is a debug label. And if there's a debug label, we're going to print what the environment looks like. This is a very useful thing because debugging how GitHub Actions are actually running is quite difficult to do in any other way. At least that's our finding. And then we're going to actually run this check versioning action. And you'll notice that it's actually part of the Smartly.io organization. And you'll also notice that it has two extra parameters we pass it: enforce and allow no release. Now this is something that is actually really nice to be able to do, is to pass parameters to make these actions that we build more flexible. So in this particular case, enforce means that if the labels don't meet requirements, we're going to return a non-zero code and the build will fail. That's it, we're done. There are cases where we don't want that to happen, so we'll set enforce to false, and it will just print a warning that nobody will ever see. The allow no release means that we actually accept the no release tag as a possible tag, no release label as a valid label in this case. When we actually get to the version bump stage, we'll see that that's not something we want to do, because if we're going to be doing a version bump, we'd like to have an actual version to bump. No release is not valid there, but it is valid here, so we'll allow that. So what about the build step? The build step looks pretty much like what you'd expect it to look like. We check out the code, and we check out the branch. The default checkout action will give you a detached head state. And I'm kind of ashamed to admit that I don't remember why I did this. I wrote that code, but I don't remember why we don't want a detached head state in this particular case. So we're going to get that, check out the branch at that point. We're going to set up a node environment, and we're going to run yarn install, lint, build, and test. And the reason those are actually separated into separate steps is because it's a lot easier to debug. You can see that the yarn lint step failed without actually having to go very far into the UI. So this one was quite obvious and kind of what you would expect to see. And then we get to the fun one, which is version bump. Version bump is a little bit longer. I really hope you guys can see this. I'm sorry, I tried to get it as compact as possible. Again, we're specifying the operating system we want this to run on, and I'm actually going to go back because there's something I forgot to mention in build, and that we only run this build when the action is the action that triggered the build is not closed. And we'll see that we actually run a separate build and test when we do the version bump. So version bump actually runs when the action is closed and when the pull request is merged. So if the PR is just closed, this won't run, and if the PR is just a commit that's triggered the action, this won't run either. So we run the check versioning action again, and you'll see that here we don't accept no release. If the label that got us through to this stage was no release, we actually just want this to fail. We don't want to carry on and do a release without a valid release tag. We also check out the code again. And in this particular case, we check out master. Since we know that a merge has happened, master is perfectly good here. And we also are not going to persist credentials. The newer checkout action will actually persist credentials, so you can keep using Git. But the credentials it persists are token credentials, and they're just for a normal user. Because we've turned on branch protection, and because the release is going to require us to push back into master, we can't use the default credentials. So we're going to tell it to not persist credentials. It saves us having to remove them. Then we go in and we do the same thing that we did with the build step. We install node. We do the install, lint, build, and test. Then we get to another one of our actions. We use learner because in this particular case, the repository we're talking about is a monorepo which includes multiple packages. Learner just manages the multiple packages in a monorepo. And when you ask learner to do a release, what it will do three main things. It will increment versions and then push those new tags to Git. It will change the versions in the package.json files, and it will push that back into Git, and then it will upload your assets. All three of these things need to succeed. Two of those things are involving Git, so we actually need to set up Git, and the third one is involving our npm package repo. So what this learner publish action does is it will take the credentials we give it, and it will put them into the npm-rc file, and it will configure Git to use SSH to be able to push back into master. And then it will do the whole version bumping with the version bump that is now a formatted string that it got from the check versioning action. And you'll notice that in this case, the check versioning action actually has an ID. That ID exists so that we can refer to it later when we do the learner publish. So this all looks very nice. So let's talk a little bit about a couple of important points here. So a few notes to make here. One, the jobs are running in parallel. We're not chaining them. So inter-job dependencies are really nice, but in this case, they're not needed. So for example, if a developer forgets to add a label, we'd actually like the build to continue. We'd like them to be able to see whether the build passed or not without having to add a label and manually rerun the job. That's more of a convenience than anything else. We use parameterized actions to simplify workflows. So we've abstracted the entire logic of checking versions or configuring the credentials for learner, and we've put them in a separate place. Those are all publicly accessible. So this slideshow will be available publicly. You can go and have a look at what those actions look like. There are no third-party actions in this. All of those are written by us, but if there were third-party actions, we would have forked the repos and we would be referring to our own copies of them for security reasons. Pushing to master requires some tricks. So we actually have a robot account that actually has SSH credentials to be able to push into master. It's not a very nice thing, but that's the only way we could find to actually make this work. Also notice that we're not triggering on labels, even though we depend on labels to actually be able to do a release. And the reason for that is if I allow triggering on labels, and I make a PR and add a minor label to it, for example, what will end up happening is we'll end up building it twice, because that's two separate events. And we want to avoid that because we end up with race conditions. So we just opted to not do that at all. Makes life simpler for everybody. So what's next for us? We're going to look into more automation for self-hosted runners. As I mentioned, we're looking into the API. At the moment, we're just adding them manually, which is obviously not scalable for 300 repos. But we're going to look at more automation for those. We're also thinking maybe we'll go all in and start using GitHub packages as well. Single point of failure, might as well have it be a giant point of failure and get more of that sweet, sweet integration. We're also going to wait for new features. And for us, this kind of makes sense. What we'd like to do is get GitHub Actions to make our lives easier. So we're not very keen on building a lot of our own tools to do things that we believe that the automation platform should be able to do for us. So until we have more organization level features, we're probably not going to expand this past libraries and some Kubernetes services. So the question is, are GitHub Actions for you? And I'm going to be honest with you, if you're hoping that a meetup is going to answer that question for you, the answer is probably no. Smaller builds without complications are probably worth experimenting with. But the lack of organization features might well be a deal breaker for some people. Some organizations might need that type of integration, might need to have better metrics and better notifications. I honestly can't answer that question for you. It might be worth waiting, it might be worth experimenting with. We decided to experiment, we decided to dive in with a couple of different projects, and it has mostly worked out well for us. And that's pretty much it. Thank you very much. And there will be a blog post coming soon about this, which will go into more detail and probably explain how things work a little bit better. But yeah, so now we have questions.